Hello, everyone. We have 0 viewers, so for future people watching this, we are starting a live stream where every week we meet to do some Rust. We are beginners at Rust, just not to say noobs. And we are trying to learn more Rust by solving Advent of Code challenges. So we have a repository that you can find here if you're curious, where we have done, I think, the first 10 of last year. And we are progressing today with number 11 of year 2020. So every time we do this, we kind of rotate around. So somebody is driving and the other ones are suggesting and making fun and trying things and screaming at the borrow checker. So we'll try this again today. By the way, I am Luciano.
Roberto.
Eugen.
Okay, and today I think we say that Roberto is gonna drive, right?
Yeah.
I think so.
So I'm gonna show Roberto's screen and we can get started with this exercise.
Okay, so better jump to the Readme.
Yeah, good first step, find out what we need to do.
So, sitting system. Who's Readingme? Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you are so early nobody has even arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, you are pretty sure you can predict the best place to sit. You make a quick map of the seat layout, your puzzle input.
Okay.
The seat layout fits neatly on a grid. Each position is either floor, that is a dot, an empty seat, that is an L, or an occupied seat, that is a sharp. For example, the initial seat layout may look like this. Okay?
Okay.
Now, you just need to model people who will be shortly. You just need to model the people who will arrive in shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats near to a given seat. The 8 position immediately up, down, left, right, diagonal from the seat, like the game of life.
Okay.
The following rules are applied to every seat simultaneously. If an empty seat, then an occupied seat. Okay, if a seat
it's
is
literally
empty,
the same rules as the game of life, basically.
if a seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied. If it is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Otherwise, the seat state doesn't change. The floor never change. Seat doesn't move and nobody sits on the floor. After one round of the rule, every seat in the layout occupied become occupied. Okay, cool, thank you.
So the first state that everything is empty, every seat
And
is
everything
empty.
is
So
full.
the second state, every seat is occupied.
Okay.
After the second round, the seat with 4 or more occupied at the same seat will become empty again. This process continues for 3 more rounds. I believe it. At this point, something interesting happened. The chaos stabilized, and the further application of the rule caused no seat to change state. Once people have moved around, you count 37 occupied seats. Simulate your sitting area by applying the seat rule repeatedly until no seat change. How many seats end up occupied? Your puzzle answer is a lot. And our
Alright,
input
so
is...
just to get this clear, the idea is to rerun the rules for occupying seats first on a completely empty grid, and then on the grid as we occupy seats in it. So like you do one run and you seat people, then you do another run and you empty some seats, then you do another run and reseat other people and so on until it stabilizes.
Until for 2 turns in a row you see exactly the same structure, basically.
Okay, so we need to keep track, well, either check the results against the previous results, or we need to keep track of the number of moves we do, maybe? And at the end of the run, see if we were either emptying or moving anything, right?
I think we can just keep the previous state, the new state, and if they are the same, we stop.
Okay.
Also because we have to do this in an immutable way, because the changes happen simultaneously, so we can't rewrite over the same matrix. We have to create a new matrix, start with the old matrix, apply the rules for every cell that is not a floor. If it's a floor, we just copy it by. Otherwise, we apply the rules, and when we have previous and current that are the same, we end, we count the seat, and we return the number.
Yeah, so I suppose if we want to abstract in steps, the first step will be to have a structure that is probably a vector of vectors that represents the bidimensional space. And then we need to be able to parse our input, populate this vector of vectors, and we need to decide what is the type. Probably we can use an enum or something like that. And then we need to have a function that allows us to generate the next iteration of the next generation, let's say, of our grid. And then we can keep calling that next until we see that the current value is the same as the previous one. And at that point, we need a function to count the number of occupied seats, right?
Yeah. Well, even checking the values could be an expensive thing, I'm thinking now, if we're checking 2 grids against each other, right?
Yeah, it is expensive, but the first difference you stop. So
yeah, it does have an early exit. Although worst case.
Worst case is just the last cell that is different. You have to check all the 2 matrix until the last cell, and then at that point.
Yeah, it's fine. Let's start this way because I suppose working is definitely more valuable than perfect. So yeah,
so
cool.
you want to create an enum?
An alternative could be that in our next generation function, maybe that's a little bit more optimized, as we copy values, we can also have a flag that says, did anything change? And we also return that.
So we can return the new state and the boolean. The boolean is something changed, and if that boolean is false, we stop. So we do a while that boolean is true, or a loop, and then we break on that boolean being false.
Yeah, that sounds better actually. Nice idea, Eugen. I like it.
Okay, so vector of
I think we can start with an enum. We can create an enum that
representing the cell.
Yeah, 3 types essentially.
Can we steal it from some of the older tests?
I can tell you how to do an enum if you don't remember.
No, I remember absolutely nothing.
So you can just say enum and space. Let's call it, I don't know, cell or cool. And then you do curly braces. And inside we have to list all the options with uppercase, with the same camel case syntax. So we can say floor, occupied, and empty, something like that.
Comma?
Floor, comma. Make it just the first one uppercase. So it's camel case, it's not...
it's not uppercase. It's...
Okay. Yeah, it's like a class name if you want. Or we can call it, I don't know, empty seat and occupied seat, or just empty and occupied, whatever you prefer. Exactly. And now what we could do is, I think we can implement something like from char or something like that. That gives us the cell starting from a char. So then we can iterate in the input.
Yeah.
So you can do impl cell and then curly braces and do fn from char.
Close.
And yeah, and then let's say C column char, I guess.
Yeah.
And this returns, if you do an arrow, like dash, yeah, and this returns a cell. And now we can use match C, and again curly braces, and you can do single quote because it's a char. And what are the options? Dot is a floor, so you
Dot
just
L and hash.
now you need to do a fat arrow, so equal and the angular thingy, and just say cell column floor, and now comma, and we can do all the other cases.
This was empty, right? Yeah.
Yeah. And
It actually looks like an empty seat, right? The L shape.
Yeah. It does. The hash doesn't look like an
and
occupied
the hash,
seat, but sure.
I don't know.
It's like a weird bug.
We need some imagination, right?
A lot of it.
Now you need to do a default and maybe just panic. So yeah, just do panic lowercase and just say invalid cell or whatever.
Invalid char, maybe.
Invalid char, sorry, yeah.
Double quotes for this.
By the way, panic, you can also use it as a format string, so you can put the curly braces and then you can pass additional arguments. If you want to say invalid char, whatever was the char.
That might be nice, actually. Because we know our input is safe, but so if this was actual code...
We can format it like this, you mean? No.
Yeah, without the C. So just leave the... And then you do another argument and you pass the C. Yeah, that's it. Cool. And this should be good enough for us to do the parsing. Now we can do a vector of vectors of cells, right? That will be our grid.
And I'd suggest we do it in the... Oh, hang on, I think Roberto's reading.
Sorry, I was reading that want a snake case, so...
Oh, yeah, that's... Yeah.
Okay,
it's never used, that's fine.
Pretty much like fine. Python there, yeah.
And the num is never used.
It will be.
It will be. So, now, inside our...
Yeah, let's do it there, and then we can see if it makes sense to do another struct with maybe a struct called map or whatever that contains the vector of vectors.
I don't know if we can call it map. Is it not a reserved keyword?
No, because that's an hash map.
Oh yeah, they don't have generic map. You're right. Sorry. Yeah.
How do you want to do? Do you want to do a board or a... I don't know.
I think we'll need to implement all the methods like next generation and so on. So it can be nicer to have a struct, but we can refactor later, whatever you prefer.
Oh, well, let's start with the struct. Come on.
Okay.
I don't remember the syntax at all, even of the struct. So
let's call it board, so just uppercase. And now again, the curly braces, and we need to specify all the fields. So the first field will be, I suppose, board. And board is
vectors,
vec
I guess.
Of vec of cell. And that's pretty much it, I think. For now, we don't need anything else, right?
Yeah. Can we do an alias instead of struct?
Yes. I'm not sure, though, if you do an alias that then you can implement functions.
Yeah, let's give it a shot.
You know what we can do? We can do a tuple struct. So rather than doing curly braces and board, you just put parentheses and then pass directly vec of vec. So this is basically like a named tuple or something like that. Actually, I don't know if it's like a name,
Do I
but
need a
basically
semicolon?
you have only one field that you can access with 0.0. But then you can call this type board. So it's like doing encapsulation, but with a simpler syntax.
Do I need a curly brackets here or
I
not a
think
curly brackets, a
so.
semicolon? Sorry.
You need a semicolon. Yeah, I think so. Not sure, actually.
Well, without what was complaining about.
Yeah, you need that then.
Okay, that I need a semicolon, so let's put it back. Implement board, we call the function next. That,
Or do we want to do a parse, like a from string
yeah.
or whatever? From str, whatever we want to call it.
From str, and we pass the boolean input.
Yeah, we can do that.
Okay.
Reference, yeah. Or do we want to consume the string here, maybe?
Don't know. I think we already have a reference because it's a static string.
Yeah, it's passing us a reference, so let's pass on
Okay.
the reference and not anything strange.
Sure.
Oh my god. Okay. Here we initialize the vector of vectors.
Yes. Let's call it.
I can use board, or I need to use the macro here.
No, you need to use. We need to create first a vec of vec cell. Then with that we can create a board. Like you need to wrap. So the board is actually a type that is wrapping the vector of cell.
So first stuff, return that is my board. I have to create just a structure vec of cell to contain the vec. Then we create every single row and we append the row to the ret.
Exactly. And then at the end we return board parenthesis ret. Or whatever, yeah.
Yeah, we have to return board of ret.
Yeah.
Exactly.
And this guy is, like we said, a vec. So yeah, vec of cell.
Oh, it's understanding it on its own because we are using that return. That's pretty good.
Okay, but why if I do equal now is something... because it's parsing. Okay, sorry.
So if you do now vec exclamation mark, I guess, and square brackets, let's see. Yeah, it's figuring it out because...
it's figuring everything in automatic. Oh my god.
Nice.
I'm worried about this.
It's remarkably, smart.
So now we have input, we have to iter over the lines.
No.
Yeah. There was a way to iter over the lines over the input.
I think it's input.lines.iter, I think.
Lines.iter. Okay, cool.
Into iter.
Iter or into iter? Probably we can just do iter.
I don't remember. Let me take a look.
I think iter will work as well.
Scusa, non credo di aver capito.
My Google Nest.
Google doesn't like it.
Yeah, the Google is not understanding, sorry. So let's do for row in this guy. What we do for every row in our input. The dot iter when you do a for is needed, or can we omit it?
I think it depends on the type.
No,
but I think lines is already an iterator, so it should work this way.
Yeah, it's giving me a pointer to a string, so a reference to a string, so we are fine. Now we need to declare a mutable line that is of type just vec of cell, and is again a vec.
Yep.
And now for all the C that are char in my row dot
chars,
There is
Yeah.
a way to have all
Yeah,
the
yeah.
charts.
I
It's
think
you
there
passed
is
it.
charts. Yeah.
You passed it. It was suggested just above. There it is.
Chars.
Chars.
Okay, so C is a no. This is not Python. For C in that one, line dot push and my
C.
cell
From
from
chart.
char C. Oh, pointer to C. The reference to C, not pointer. Sorry.
And
So
now
I'm still,
semicolon there.
I'm still doing C, guys. This goes there, and this is complaining about.
We need to push the entire line, right? At the end
Yeah,
of the...
yeah, yeah.
Oh, yeah.
After for each row, we have to take ret and push pesh. Push everything inside it. Okay. So at the end of all of this, we have parsed our input and we're returning a board with our vector of cells.
Do you want to put that in part 1 and we can print it out and see
Oh,
if it
by the
actually
way,
gives us...
in order to print, we can
We have to implement a debug trait,
exactly.
right?
So that will do all
yeah.
the magic for us. And
Yeah,
so
I have. Don't remember.
So if you go to line 17, you can use the hashtag, square brackets, derive, all lowercase, and then parentheses. Cool.
Debug. Nice.
That's
It
what we
knows.
want. Right.
Cool.
Oh, it's
Oh,
not
and
happy though.
we need to do the same in cell because it's making sure that all the nested types are also debuggable. Okay, now at this point you can create an instance and then you can use the print macro to visualize it.
Is it gonna pass it as a... Yeah.
Yeah, I wrote bored instead of bored. Never happened. We don't have proof that happened. Oh, this is recorded. We have proof. So print line of board.
I think you need the... That might work. I don't remember.
What I need?
I think you need to pass it as a string. So do a template string and then pass it board as an argument.
Ah, it's true. How it was like this.
Nice. And then...
Yeah, the comma.
Comma, yeah. I think.
No, it was like this. Okay.
Yeah.
Colon.
Right.
Question mark. Okay, if we run test 1.
The moment of truth. Let's see.
Oh my god.
Oh, wonderful.
Floor, empty seat, floor, empty seat. Yeah, because the first step is...
But this seems to be a single array.
No, there is a block.
Okay, cool.
See.
It's just not
Good.
easy to visualize.
Yeah, this is the
tricky.
skip. This is the skip between rows. Can we teach him to print a pretty matrix instead of this shit?
We can implement a toString.
To do it like line by line, do you mean?
Yeah.
No,
that would actually be nice.
No, to put a sharp where it's needed, to put an L and to put a dot. Basically to print out what we had before. So we are parsing a string and then unparsing the string.
Deparsing it, yeah.
Yeah, the parsing it just to print it because
Nice.
it's cooler.
No, it's fair enough. It's easier to read anyway.
So here in the implementation, how do I do that to string stuff?
So we need to do it first for the single char, right?
Right.
But there is a trait that we can implement. Give me a second that we can find it. I think it's called toString. So it allows you to implement toString. I'm not sure what's the name of the trait. So let me do a search.
Implement toStringable.
ToStringable, yeah.
Sorry.
Fast to string trait. Okay. So, oh yeah, it's just called toString with uppercase. So you can do impl, another block.
Can I stay in this block or you have to
No,
implement
it needs to be another. When you are
Okay.
implementing a trait, needs its own
its own
impl
block? Okay.
So it is called impl toString with uppercase T and S. No, sorry. In the first line 19,
Yeah.
it's called implement toString for cell.
So toString
Implement
capital
to
2.
string for
cell.
cell.
Okay, so this is basically you saying I want this type to implement the specific trait toString,
Okay.
So the
forces you to implement a function called fn_string. No,
single
sorry.
fn.
Just
Okay.
yeah. Exactly, and that needs an ampersand self and returns a string.
Sorry, I lost the keyboard. Self. And you said, sorry?
No,
It
and
returns a
that's
string.
the only argument, and then you
Okay.
return a string as an object, so uppercase string.
Uppercase string, or we want to return a char from here.
You are forced to return a string from this type.
Ah, okay.
It is called toString, so
Yeah, makes sense.
it's only fair.
Yeah, it will create
Yes.
a new heap allocated string basically every time you call toString.
So
We basically
let's
need to do a reverse match here.
memory and memory throw at this.
Exactly, yes. So here what we need to do. Oh, now I see what you mean if we can return a char. We could have done that, but not in this trait.
No, but let's do with this trait. Come on, it's not.
Okay,
a
let's do it this
problem.
way. I mean, we don't need to over-optimize. So yeah, now we need to do the opposite of the previous function.
Yeah, it's just looking that you want references to stuff.
I don't think it needs. I think this one is correct.
Write one and let's see what happens.
Oh yeah, now you need to do string from string.
Yeah.
Colon.
Yeah.
Why is complaining about self? You don't use self like this? Or
Maybe
this?
No, maybe it needs the ampersand. No, it is definitely self. Okay.
Still not happy.
No,
What
no,
does
like
it say?
Maybe it's because you are not implementing all the cases. Or...
Non-exhaustive.
I'm still writing the stuff.
Yeah.
It's just complaining.
And in this case, you don't need the default because
yeah,
you
because
are
it's
exhausted.
impossible. So the empty is this, the occupied is that. I save, and all the problems.
Okay, now it's up.
And here I'm already returning because it's the only.
Yeah, it's the only
expression in there. Okay, so I also have to implement this for the board.
Exactly.
Mm-hmm. Yeah.
For board. Close, save.
You've got, yeah.
So now here we have to cycle over the element 0 for line in
Self.
Self of, oh my god.
Self dot 0, not square bracket.
Dot 0.
I think that's why it's trying to do like a slice or
was
something.
doing magic.
Why? Because we're using a tuple. Okay, gotcha.
But we can map this. How is possible to map this? So line
dot map. Yeah, I think we can do that.
Dot iter dot map. No.
You're in the arguments.
Map. And
we have somebody suggesting self dot 0. I don't know what that is.
What are you saying? Sorry, I got lost.
We have somebody in the chat suggesting self.0.
Where?
No, but I don't think it's a real suggestion.
I can't see the chat. Interesting.
Me neither. So only Luciano can see the
If
chat.
you go in
Perfect.
comments, you cannot see it.
Ah, comments.
Go-
Whoops. Yeah. Yeah, you're right. Sorry, my first time using this, so I don't really know where I should be looking. Apologies.
Okay,
neither, don't
so
worry.
there you can do...
To string.
Oh, okay, yes.
Strength.
Strength. But who is not using a strength? Everybody must learn to use a strength a little bit more. From my God, from X. No, it's not happy. I wrote shit. Oh, well, I do
think
nothing with this.
we are not doing anything with
Yeah,
it yet
sorry.
because the map
Oops.
is lazy.
Yeah, so we have to convert.
We should collect into a string, basically.
Yes, should
Yeah.
collect. We have to join all together because this is this point is a vector of strings. We have to join
Yeah.
them together.
And the \n, probably.
No, this is the line. So we have to join them with empty string in the middle.
Or comma.
But even the single line, if you just do the map this way, is not consuming the iterator. We need to call something like dot collect
yeah.
at the end.
I'm missing.
But
some
we need
brackets.
to... No, we need to declare this as a variable if you want to collect it somewhere.
Yeah.
So dot collect is a function call, but it needs to be stored somewhere.
Assign it to something, yeah.
I'm running
I don't know if
out
you
of them.
can-
Transformed line, it's fine. This line, okay, that's great.
And you need to
Sorry,
give it a
Emre.
type as a string.
Yeah. And then collect at the end. And it...
Yeah, but we have to join. This will become a map of strings. The vector of strings. How do we convert
I
a
think
vector
you can
string?
call dot join on it, if I remember correctly.
I think there is a way to do join. Let me search for it, yeah. For
I
sure.
don't remember if we used it though. So roast join vector.
A vector of string.
Oh, you wanted to do everything in one go? Like as
No,
a
just
one...
Just a single line in one row. Then we append it to.
I'm not sure what collect does with a string, with a sequence of strings. We can try. I'm sure that if we did the from like the two char that you were suggesting, you can collect a sequence of chars into a string.
Oh, you don't need dot iterations already. No, isn't a map iter?
Yeah, it's already an iterator with map.
He's not suggesting me the collect for some reason.
Okay. What is the error there?
Expected struct.
The map is the problem.
I think it doesn't like...
Oh, also, by the way, in this case where you have just a function with one argument and you are calling another function with that one argument, you can remove all of that and just leave string from. So that's for sure an optimization.
Okay.
Or yeah, at least nice syntactic sugar.
Because here we are returning nothing. Okay. Okay, let's write some boilerplate. String board equal to what?
String from
String.
empty string.
String from an empty string. And then we return board. And so board is up. Now we have a little
And
bit
also
less.
remove that string in line 49. I can see you have been doing some Java lately.
Yeah.
No, before board,
Type-
line 49.
You've got the
sorry.
type declaration before the...
sorry. Yes, Java, sorry. I'm missing up stuff. Oh my god, I'm stuck.
Nightmares of Java.
Yeah. I dream of it
Okay.
at night. Collect.
Okay, so probably we can... Oh, wait, string from... But do we need to do string from...
we have to convert the cell to a string and join
Can
the string
you...
together and get the line.
Sorry, can you replace string from with... what did we call it? Tile? What did we call... Cell?
Cell.
Cell and then to string.
And remove the...
Without the parentheses, yeah. Okay. That's why it makes sense now, right? Now it's a string that is made up of all the substrings that are coming by mapping every single enum.
Okay.
So I think the only issue now is that self.0 thing, which I think we got an answer for in the chat already. Self.0 as a word.
Oh, we have comments in Italian. I have no idea what alloy is, by the way.
Me neither. Okay, unusable variable. Okay, give me time. Now, can we concatenate strings in Rust or not?
We can, and let me search for it. String join. I think there is.
There is a join on vector, by the way, if you want to do that.
So you want to... Sorry, go on.
Right, we could do like a vec of strings and then do a join.
Yeah.
Another alternative could be that since we already have a board, we can do push. We can do it mutable and you keep pushing there.
It is mutable.
Or we declare it as a vector of string, and that is a new vec exclamation mark of nothing. And now it's complaining because I don't have to use the square bracket. That is Python. Again, Python typing, striking again. I have to use the angular brackets at this point. I have to do board push this line.
By the way, I remember now what alloy is.
Okay, can you tell me, or is it a secret?
It's like a formal verification language that I had to do at the university. I'm gonna say this publicly. I totally copied on that exam because I didn't understand anything. So thank you to whoever was my colleague that helped me out in that exam.
Good man.
Okay, so now you say that the vec of string board we can join it, but is
you need to pass a string. You need to pass it a string as an argument with what you want to join there.
At this point, we have to join on new line.
Nice.
So if I run again, instead of having that shitty input, we must have back the input.
No, wait. If you use the bug, wait. How are we printing it?
With this.
That's the debug version. So now if you remove the semicolon and question mark, I think we'll see the two string. Let's see if that's true.
Nope. Pim, pam. Nothing is working perfect.
Oh, okay. Then just do dot to string. Otherwise, we need to implement display, which is another story.
Too much time just for debugging something.
Nice.
Cool.
Okay, I'm not going to check if it's like the input because I believe that. And also there are no occupied seats, so it must be quite similar.
Seems alright.
One thing we can do as a quick test is we could create another board, literally copy-pasting from the README, one of the small ones, and do another to string, just to see if that looks the same.
So you say, let's go in the README, take a smaller version of this
guy.
yeah,
one of any of these ones.
Yeah,
you can actually take one with occupied, that's good, yeah. Because we get to check if our enum works as we want it.
And you want to use it instead of input?
No, just do another line in the test. Or even in part 1, wherever. And you just create a new board.
Okay, let board 2. equal of a board from
and you literally can do a string literal there.
Which is going to look absolutely wonderful.
Can be multi-row.
I think
It's going to explode in our face.
I think it's gonna explode with the tabs. So you need to de-indent everything. And then there is a way to do string literal. I think there is like a hash or that you need to put in front of the string. But let's try it this way. Let's see if it works.
And then we print board 2.
Yeah, and we also print board 2.
And at this point we can compare this more or less.
Yeah.
Let me copy again. Let me execute this. Okay, and if I try to find it, okay, find is not working, but let's compare visually. Sharp L, sharp L, dot L, sharp, yeah,
Seems correct, yeah.
Seems correct, okay. Parsed and unparsed an input. It only took 44 minutes, cool.
Nice. But we did learn about enums, about traits and enum types. So
yeah.
Oh, yeah.
About madness in general.
You did put a disclaimer at the very start that we're noobs. Oh, sorry, beginners, I think you said, not noobs. So there.
Noobs is fine as well. I am a noob for sure.
It's quite true. Okay, let's go on. And now we have, let's comment out this.
Now I think we can implement that next method, right?
Yeah, we have to implement the next method inside the board, because a board is giving me the next board. So I can implement, yes, I can implement here. Yeah, it's not in the trace.
Yes, you can. It's our custom method. It's
yeah,
not
this is our custom method. That is taking self.
And returns.
You do it with the ampersand, so you are not consuming it.
And you return.
Do I need... we are calling the board.next, so self is the first implied parameter, correct?
Exactly, but we don't need any other parameter, right?
Yeah, and is returning a tuple, we were saying, of types, board again and a boolean.
Yeah.
So a board and a bool. Is this enough?
Just normal parentheses.
Rounds.
Round.
Yeah.
Sorry. So it's returning a board and a bool.
Okay.
Okay. So we can create the next board.
Yeah,
right,
the naive way will be that we do a new empty board and then we iterate over and we keep filling. But probably we'll need to create helper methods for, I don't know, counting the neighbors and all this stuff.
Yeah. So basically like before, we create a vec of cell and then we return a board wrapping the vec of cell.
Yeah.
Cool. Now we have to loop through our X and Y. So there is something like the enumerate in Python for Rust. So if I want...
it's literally called enumerate.
Cool. So for Y and row in enumerate? Or
no, you need to call self.0
self.board
.iter.enumerate. So enumerate is a method on iterators, and that will give you a tuple. Yes.
Yeah.
Now
I
need
need
parentheses there.
I need round brackets here.
Yeah.
Yeah.
Why the editor is moving stuff alone? Please mind your own business. Okay, I can move a cursor. Thank you. So and now for X in cell in my row dot iter dot enumerate. Let me close the so I have a little bit more editor to show.
Did
okay,
you just
now
send
we
that
have
message to the channel?
Yeah.
All right. Sorry for interrupting you, Roberto.
Sorry,
carry on.
Got distracted. So now we have Y, X, and a single cell. We have to find the let neighbors. I wrote it correctly. I have no idea.
Looks alright to me, yeah. None of
Yeah.
us knows English as a first language, so it's fine.
That is cell. I wrote it correctly one times. I'm not trying luck. And we have to pass the board.
the
Self.
board.
Yeah. We have to pass cell X and Y. So this will tell this function that we still have to implement will give us. Sorry, Luciano. Can I do something like this? Self dot. Let's say X and Y, and at this point call create another function here.
Oh yeah, yes, that's a good idea.
That is taking X as U sides and
What's it
Y
gonna return,
as
though?
U sides, and return a number, a integer.
Okay, so like a U16 or something like that.
Well, is it from 0 to 8? I can return now a U8. 8 bits.
Yeah.
Yeah, optimize the memory.
No, you're right. Absolutely right.
And restart 0 for now, just to not having complaints. Right? So now the rules are: if the cell is a cell floor, we have just to copy it straight away, right?
Yeah, but I don't think we need to check the neighbors if it's floor, right?
We
should
don't
only
have,
check.
so yeah. Let's do this later.
I
Can we do
don't
with a
know, by
match?
the way, I don't know if you can do that comparison. We need to do that like the structured syntax or a match, yeah. Or you need to do if let something equal something.
Okay, let's go with.
But this one is, I think we need to check all the cases anyway. So this is good, I think.
Can we do code in here?
Can we do code? Yes, you can do. Yeah, exactly how you're doing it is good.
And like, yeah, but we have to do this only if it's. Well, let's do it always. Then we can optimize later.
Yeah, we'll figure it out later. So for floor, we don't need to do anything basically.
We have to pass a floor in the new.
You're right. Yeah.
Okay. We have to declare something here that is the new row. Let mut new row that is a of type vector of cell that is equal to vec exclamation mark
Of nothing.
like this of nothing. Okay, so we have the new row. At this point we can do with a map. No, because we are counting is a little bit more complex than using a map here, I think. We can make a map later if it makes sense, but just to keep the logic more segmented now, I will go with new row, push, push, and here I will push a floor. If it's a floor, it stay a floor.
Exactly, yeah.
Now, if the cell is an empty seat, the rule are. Can you read
I think
them?
if it was.
It becomes occupied seat straight away.
If
right?
there are more than 8 around it, I think. So there were 2 cases. So
I remember that there is.
If the seat is empty and there are no occupied seat adjacent to it, so the neighbors are 0, the seat become occupied.
Okay, good point.
And if it's occupied and 4 are empty, then it
let's do empty by now. If
empty
it's
first.
empty and the neighbors is 0, we have to add unoccupied.
Yes.
An occupied seat. Else, I don't like else a lot. I try to avoid them, but in this case, at this point, if it is an empty seat,
it stays an empty seat.
It stays an empty seat if there is somebody near. So okay. And the third case,
occupied seat. There was 4 empty seats, I think, next to it.
If an occupied seat, if the seat is occupied and 4 or more seat adjacent to it are also occupied, it become empty. So it's occupied 4 or more, so 4 included. So if neighbors are more or to 4, it become empty.
Yep.
Otherwise, it stay occupied. I can do it. Don't worry. Just give me 20 minutes more, and I can do a paste. So floor empty. If it's 0 occupied, also else empty. Occupied if 4 or more empty, else stay there. We have the new row. The new row at this level here, yes. Ret dot push of the new row. New row.
Semicolon.
Yeah.
Yep.
Sorry. And here is complaining about board of ret free implementation.
Because we need to return.
Because we have to return a tab. Okay. Let's also define let mute worked did something.
Changes.
Or
change count or whatever.
False. Oh, we need just to false, capital or lowercase? Lowercase. It's not Python again.
Yeah. It's not too much Python.
If empty become occupied, changes is true.
Lowercase.
Sorry again, I just said this.
It's fine. I understand you. I've been doing a lot of Python lately too, so.
If occupied become empty is a change too. So this guy is telling us, look, there is here is the new board.
And wrap them in round in parentheses, yeah.
Here is the new board, and if we have changes, so we can use this outside to loop. Now we have to implement this guy. This guy.
That's not too difficult, I guess.
Well, why is it red there?
Where?
Oh, because cell neighbors, you need to add self as the first parameter.
Ah, sorry.
With that's integers, why that one, yeah.
Yeah, with integers, I don't need. They have to declare the type. No, I don't have to declare that as.
No. As a reference.
No, because yeah, they are integers. So now, let's do the stupid stuff. If let's declare a mutable called return, initializing it to 0, and then return it. And then is detecting that is a U8. Thank you. Now, if our self, how do we get an element in a vector?
Not cephl though. Self. There we go.
Shh. You saw nothing. I don't remember even the basics.
You want to find the indices of the current element.
No, I want to find the Y row. So, get.
To get what? Yes, it's get, and then we need to do the unwrap thingy.
We are sure. Okay, we are sure that there is something in stochastic. Not so sure, because it can be 0 and it. Okay.
Oh, right, yeah, we need to do all the boundary check.
Yeah, we have to do the border check to not go outside the border and throw an exception. If y is greater than 0 and get unwrap, then get again x, so same cell but on the left.
Do we not want to do a little loop for these? Because we're going to have to write a lot of these.
Yeah,
like x minus 1, x minus 1, right?
Yeah, but the border check is different, and we have to exclude the center.
Yeah, but we could do like a list of like +1, -1, and all the combinations, and then loop through it, right?
And the board, how do you do the different checks for the borders?
So you always want numbers being 0 or bigger,
or our right side +1, because we have also to check on the right.
For that one, we can rely on that unwrap. So rather than doing a wrap, we do is sum.
Let sum.
Yeah, or let sum as well. Yeah.
But also for the -1, we can do that at this point.
I don't know what happens if you pass, because it's expecting a U sides. I don't know if you can pass minus something if it just explodes. We can try. I think it's a good test. Because U sides is unsigned, so I'm not sure what's gonna do with -1.
So let's go to the row above. And if we have a row above, we do something. Let's just think about it.
Messaggio in arrivo.
No, no messaggio in arrivo.
Cosa c'è da mangiare che...
Sorry. My Google Nest. I have to turn it off when we do this.
Your Google Nest wants to code as well.
Yeah. If then we can do a cycle, but let me write a couple of them just to get an idea of what we are going to do. So if we have our row get x and this is top left, then here we do ret plus equal 1, or there is a plus plus if you asked.
No, plus equal 1.
Wait. Why are we
But we
crossing
need to
them?
check if it's
We need to check
occupied,
what it
right?
is. Yeah.
Yeah, sorry. If let some cell, if cell,
Oh,
Can
you
we do
know
this?
that maybe you know that maybe you can try to put cell occupied seat inside that let some and do all the destructuring in one go.
oh, interesting.
That
So
would be very nice.
some
Instead of
cell-
cell, just put that there.
But that maybe you need to put parenthesis cell as well. Let's see. Is that gonna work? Yeah, works. Cool. Then okay, now you can just yeah.
Nice.
Okay, let me try to rewrap this. If there is a row above the current one, if there is an occupied seat in the row in positioning x minus 1, at this point we get in and we plus 1. For the row above, we can also do this
Then, yep, number
with
above.
the same x and plus 1.
Correct, yeah.
Yeah. And then we can do this again for the row
Do the row below, yeah.
and we can do this except the central one for the row in
The
which
current one, yeah.
we are, less this guy. So yeah, this can work. Let's see this working, then we can try to do that with a matrix of deltas and something more fancy.
We also
why
need
is
to,
complaining?
because it's not called.
Oh, no,
We're
we are
not using
calling it.
our next thing yet.
Ah, we are not using next because
Yeah.
the cell is used there, but it's
Yeah,
propagated.
but we're not doing the checks yet.
Yeah,
We're
yeah.
just printing the parsing. But it's fine.
Okay. Let mut loop. Can I use loop as a variable or is it an internal
I'm
word?
not sure because there is a keyword called loop, so I'm not
Okay.
sure if it's gonna allow you.
Still going.
Yeah, fair enough.
While still going. Board, comma, still going is equal to the new board. But well, we can do board, no, because it's...
Yeah, you need to make it mute if you want that.
Yeah, but also you'll need to do let and
Yeah.
parentheses, I think.
Yeah.
Okay. No, but well, those are variables that are already there.
Yeah, but you need the parentheses.
Oh, okay. Then maybe you can just reassign. Let's see. Let's put
If
the
this was
parentheses
Python, this was completely fine.
but put parentheses around the first two, board and still don't go.
Okay, it's not unpacking on its own.
Okay, nice.
Now, yes,
Well, not
complaining
nice.
about
Let's see.
distracting assignment are unstable. Oh my god, cannot assign to this function. And how do you assign to...
Okay, try to put let in front of them. Okay, so it's not gonna override. Yeah, we need to do it manually, which is a pity.
Because what it means that are unstable?
I have no idea. We need to look it up.
They are going to explode? No.
And still going.
So now,
Not very pretty, but yeah.
no, pretty, no. The previous expression was pretty, but was complaining. So let's make
So,
him happy.
Do you feel
So,
confident running
loop,
this,
loop,
or
loop,
will
loop,
it be
loop.
empty? Will it be endless?
Bah, well, if it's endless, we find it out. Now here we can do board count.
Did we implement that already? No, right?
We
No,
didn't.
but we can implement it.
True.
Oh, I like that you are making it generic, that you can count any type.
Non-def, def is Python. Today, guys, I can't do it. It's incredible. Count. Then
Cell.
we have
Cell type.
Cell. And we give back U32. I have no idea how big it can be. But, well, we have an idea. 2000. So 16 is enough. But let's throw bit at it. So now we are going to loop again on top of our guy, like here
it should
without
get a
the
self.
numerate. Yeah. And I forgot self.
Yeah. Ampersand self, yeah.
So for each row at this point, without the iter, I just want the row.
There's
We
a parentheses left.
need this, we don't need that. For every cell, for cell in, let's remove iter and enumerate, and let's close a couple of brackets. Is balanced? Absolutely not.
One more. Yeah.
So our return value is 0, and are we returning our return value? Here, Luciano, to do if the cell is of that type.
We can do that if the type, if let, and then cell column.
Well, C, because we are passing it.
Right. So let's do C equal.
Cell.
No, sorry.
I
We are
want to check if cell
passing-
and C are of the same type.
Then C is our type, so C equals cell. But it needs to be let C equals cell. I think. Is that gonna work? Maybe it works. No.
Binary
There is a way
operation
to
cannot
make
be
it
reflected.
work if we implement the comparison for the type cell. But I think if you do let C equal cell with one single equal, doesn't work.
Oh, you need to save first.
Okay. So I think this is the same logic as when we do let sum equal something. So essentially it's applying the pattern matching, saying this thing on the left side, which is a type, doesn't match the type of the thing on the right side. And with let, it kind of switches into this mode of checking with the structuring.
You know that this for me is black magic, okay?
Yeah, I took a while to figure that out as well.
Okay, black magic, cool.
But you can do a direct comparison with the equal if you implement
The trait in the enumerate, we have to implement the equal trait in the enumeration. Okay, next time.
Which is not worth it because it's an enum and we just want to check the type, not check.
Oh,
Okay,
and
now
remove
it
the
is
semicolon. Remove the semicolon and save.
Save.
There we go. All good.
Fingers crossed.
Let's see.
1, 2, 3. Boom.
Let's
Explode.
Oh, okay. Self of 0.
Move occurs. Okay, so we have to use the end, line 120. Because we have
Star.
to borrow the stuff.
Oh yeah. What?
And at this point we have to have reference. Okay, and at this point we have to pass a reference when we count. Okay.
Okay.
Okay, this borrow checker shenanigans part 1. Okay,
What?
now what happened? Warning. If this is intentional, prefix it with underscore.
So there is a C that we are never using.
In the count. That let is not exactly working.
Line.
Okay, you know what? Let's make this method a little bit dummier. Let's not pass the type and let's just check that the type is explicitly a occupied seat.
Okay, let's go dumb.
Maybe we can rename it count occupied later, but whatever.
Okay, let C of type cell occupied equal cell.
Oh
at this
no,
point.
here you can just do cell occupied equals cell. Remove the C column at the beginning. Okay, I'm quite sure this works.
So here we are saying if the cell is of this type.
Exactly, yeah.
Okay. I have to say it's not the most straightforward syntax, that, or at least I find it a bit confusing now.
Yeah, for enums is weird.
Panicked, attempt subtract with overflow.
Yeah, I was expecting that. Let's go to that sum.
The sum is not. Because
not
you sides can't be negative.
Exactly. So there is a 0 that we are doing -1 basically, and then using it as a u sides.
Okay, so if y is greater than 0 and
yeah, we need to do this shenanigan everywhere.
X is greater than 0 and
you need to do ampersand.
Sorry?
Instead of and letters, you need to do ampersand ampersand. Like
Thank you, Python.
Yeah.
Thank you, Python. Okay. And now it's complaining because I can't let after a check.
Oh yes.
But I can't do anything. It's so picky. Oh my god, so picky. Yeah, now the same here.
Yeah, I think this is one of the features that they want to implement in the next releases of Rust.
In the next episode of Rust, will be our heroes able to do something today?
Our heroes are very close.
Almost
to the door. Okay, obviously I needed to reformat this, but not now.
Well, let's see it run.
I'm not finding the run, okay. Yay! Passed!
No way, nice.
Okay, this worked.
Try to change one number just to see if it's really working.
If it was just luck. Let me just... No, sorry. Wrong combination of keys. B, thank you. Control Shift this one. Format document. Formatted for real. Yes, this function is horrible to look at. But,
yeah, we need to fix that.
Yeah, we need to fix that. Also, this one is not super pretty, but well, at least it is clear what she does. But this function, my god.
That reminds me of some wonderful PHP code from many years ago.
PHP is always wonderful.
Which I may or may have not made myself, but hey.
Okay, so you say let's change a number so we can asserting another number in the test. No, what do you want to change? Sorry,
I mean,
well,
I suppose it's working. We don't really need to do anything.
Let me take the input and mess with it. If I put the floor
change
here, just remember the first one was an L, and I run it again. It must fail.
Yeah,
Failed.
it did. Cool.
Okay, but we could have failed or not, depends. So save, go back here, Ctrl B, run test. Okay, cool.
Okay, so
And-
we actually solved the first part.
Yeah,
We might make it a little bit nicer, but we did solve the first part. I don't know if you want to spend more time for today,
fine for me. Until
because
my one.
if we have, I don't know, we can start to look at the second part or invest some time simplifying a little bit the logic.
You know my preference on this. Let's make it pretty now that we have
Yeah,
it
also
working.
the second part might not be super short.
Now, I will be honest, I don't have a lot more time left. So I'll
So maybe
disappear.
one thing that we can improve is that 1 million of if statements.
Yeah.
One way that I was thinking is that we can do an array of tuples where every tuple is like the dx and dy. Exactly.
How do you declare a tuple literally?
So you can do, if you put square brackets, I think you can do a slice, which is the equivalent of yeah, okay, let's do that, and then you can put parentheses, regular parentheses. Exactly, and remove the square brackets and keep doing that for all the combinations we want.
That
Which is
are
gonna be 8 of them,
8,
right?
4, 8. Let me format document. Tac.
Nice.
Why the type is E32, colon, underline?
Because that underscore means the sides. So when you do, let's call it array. I don't know if array is the right word. I think the right word is slice. When you do, let's say a slice, you need to specify the sides. But since here we are doing a slice literal, the size is implicit because it's going to be the number of the elements there. So that's why you see the underscore.
So, -1, oh, the row above, all of 3. The row only left and right. The row below, all 3 of them. They are 8, so we can go up to 8. And now the shenanigans about...
Okay,
So let's do a for loop for delta
Door.
for delta y and delta x in my offsets.
I don't know if you need ether. Let's see if it works. No, it works. Cool.
No,
Or
it's
not.
complaining.
And then try to do dot ether.
It's not an iterator.
Okay, nice.
Nice.
Now we have it. The new coordinates, so the new y is y plus delta y. The new x.
Oh, now it's gonna complain that you are summing a u sides with a I32. Yeah.
And you need let's before that.
Okay, so
No.
the way you work this one around is that you can say y as u30. No, sorry, y as I32.
I have to put it in square in round
No.
brackets.
Well, I don't think it's needed, but
It's more clear for me if you don't mind.
I think it works either way. Yeah.
Okay.
Okay, now we have our new if new x is less than 0 or new y is less than 0, continue.
Exactly.
At this point
And
we have
or
to take...
you need the double pipe to do or.
Again.
Not Python.
Not Python.
Not yet.
Not yet. It's so clear, or why you have double pipe? Double pipe is so see.
Yeah, we need that something now. Yeah.
We have self of 0 get self of 0 get my
New Y.
but we have sum. We have to use the sum.
No, it's gonna.
No.
I think this is gonna destructure nicely now.
So this should
No,
be...
but when we have one more item when we go right and bottom.
Yeah, but you are not gonna see the value, right? It's not gonna be something. It's just gonna be none. So it's not gonna go inside the if.
And you also need to get the row itself. I think you can do it in line.
Oh, by the way, new y now probably you have to say as u sides. This is a little bit annoying, but whatever.
Okay.
If anyone knows a better way, let us know in the chat.
That's a good point. Can we, by chance, do this in line? As in...
Everything in one line? Here we are asking Luciano, but at this point I think we can get rid of all of this.
In one line, you mean to do a double sum?
Yeah, like get both the row, get the element itself, rather
me
than
check
get the
if
row
this
and then do
test
another
has
if
still-
inside.
Oh, actually, you know that maybe we can do it.
Okay, tests are still green. Cool.
Nice.
good.
Okay. So we could try, but it becomes a little bit unreadable, to be fair.
That's true.
Oh,
It's
like
already
this,
a bit unreadable, so it's fine.
Oh,
Yeah, we
like
can leave it.
this. Sorry if I enlarge a little bit the window. Still readable. Thank you. Give me some breath. Sorry, I have to remember to silence the phone.
Yeah, I suppose that we can use the dot map of optional type.
Yeah, but no, this is okay. Although it's still nested ifs.
But two of them, come on, it's not 100.
Yeah, no, I think this is more readable because what we could do is in the first self 0 get, what we could do is dot map at the end, which basically should check if the optional is none, it's not going to do anything, it's just going to return none. If it is sum, allows you to map that value to something else. So we will do get again and return directly the cell.
Okay, let me try if let
Sum of cell occupied, and then you can go
sum of cell occupied seat equal to this
Self.0.
dot map or amp.
And then you need to pass a closure where you have row, basically is the parameter. And then you do row.get index, whatever.
Okay, so I do this.
Oh, you don't need the little arrow, it's just
a pipe, yeah.
Okay.
In
this case, it's like Ruby.
If let all of this
return
plus
plus
equal 1.
Yeah.
Okay, let me comment out this.
I honestly think that the previous one is more readable, but I'm curious to see if this works.
Okay,
it's
this
not
is
happy
complaining
already.
about something.
What's the actual error?
Types mismatch. Option of cell instead of found a cell.
Oh.
Yeah, but it's not
Then
some getting rid of some.
Maybe we don't need to use map or something else.
This is super readable, guys.
No, there is a way to resolve nested sums.
But this is a way. I wrote some 2 times.
I think if we don't use map, but there is another combinator we can use instead of map.
Okay, let me just check if this is green, if this is still a valid syntax and a valid... Okay, so this is Rust. So it's
But
not
the first one does look better.
So, but
none of them looks good, but the first one does look better.
Yeah, there is a different way to do. Rather than map, there is something else. Let me see if I can find it.
Okay, because here we are doing if some occupied cell self 0 get map.
Flatten, maybe? Let's see.
Yeah.
Converts option of T into option T. So I suppose if at the end you say flatten, after the map, if you say dot flatten, then
Okay.
maybe you don't need the sum.
Okay, just one sum.
It's
And after the dot map, I do a
dot
flatten.
flatten.
Flatten now, we want to say.
It works, but it's not.
Yeah, I still think that the previous one is more readable.
Hey, it was worth a shot.
Still good. Oh, compared to the dot flatten, I prefer the double sum. Sum. But compared to the
I
sum,
don't know.
I prefer the previous if.
Yeah, exactly. Me too.
We can leave this commented just to show fancy Rust, but
Oh, you know what else we could be use? Which maybe is a little bit more readable because you don't have to use flatten. Rather than map, you can use unwrap or,
die. No.
which literally means if you can unwrap. No, wait. That's maybe the opposite because that's have a known, you can map the known to something else.
So is there
So
something?
no, that's the only way.
Okay, so
I guess.
let's remove.
Ooh, there is a guy that we know. Hello, Podge.
Hey, Podge saying booptly.
Boopity boopus bop.
Okay, so let's maybe leave it at that for today.
Yeah, let me just commit.
Yep.
So just to refresh, we have our repository here. If anyone is curious to check out our progress. By the way, this is our first attempt at streaming our Rust sessions, so any feedback is most welcome. You
Like
can find
learn to type on the keyboard is a good feedback.
Yeah, also Roberto accepts donations. You can buy him a new keyboard if you want.
Yeah. I have a beautiful keyboard, guys. Beautiful keyboard.
Nice, with a rounded button.
Logitech, send me more keyboard. I will review them. Logitech, send me keyboards.
Nice.
So this is working, guys. Unbelievably working. Next time we do the second part.
Yep.
Yeah.
Okay.
And if you want to have a preview of the second part, because it's actually quite interesting, I already checked, so spoilers.
Spoilers.
Basically, the rule is pretty much the same, but there is a rule where in order to decide like the neighbors of a given cell, it's not just the neighbors around, but it's literally the first visible seat in every direction.
Ooh.
So we'll need to kind of cast a
Diagonals included.
Yeah, diagonals included.
Oh.
So
cool.
it's not super complicated, but yeah, there is an extra layer of complexity.
But basically, we have to take the same test that we have and change the neighbor function.
Exactly, yeah. So
Pretty
we could
much.
implement another function called next to that uses another neighbors or whatever.
Yeah, so we have to implement another one for this in the same board. We implement another function. Then in the test part 2, we have to just do a next that is using the other function. We can keep the same logic for next. We just have to change this function. It's possible to pass a function as a parameter to a function in Rust?
I think so, and that actually is an interesting topic because there is we enter the realm of closures, so we can play with that.
It'd be cool. By the way, we have a question in the chat about if we schedule the day for the second part.
Yeah, so we haven't been super thoughtful about this yet, but what we do is generally we meet once every week. Generally on Monday. For this week, we did an exception to meet on Tuesday. So we'll put the schedule on Twitch. So follow us on Twitch. and it will be probably next Monday or next Tuesday. So yeah, please give us a follow and stay up to date.
And thanks for the
Okay.
question, and thanks for the interest as well.
Absolutely. Yeah. Do we leave it at that, or is there
Yeah.
any final remark?
I'm fine.
No remarks from me. I had one and it led us down an ugly path. So
Well, thank you also, Roberto, for driving. So next time we'll see somebody else being very bad at typing.
Yay!
oh yeah. Cool.
Okay. See you soon. Thank
Thanks
you.
and see
Bye.
you.
Bye.